And yet we're hitting you yet again with another math video. And as you can see, we're trying to flood the market. We're putting out almost one math video every day. And so if you love math, if you love this content, please like, subscribe, and comment, because we're going to keep it going. We're going to flood the market.
Specialize in science and math, original black men, busting thoughts that pierce your mental, the fierce, ripping your section, vocal toe to toe, impeccable, splitting your back, son. Simple as addition and subtraction, black thought, the infinite relax one.
Greetings, math people. This video is all about arithmetic tricks. So I'm going to show you some of the arithmetic tricks I use almost on a daily basis to do the calculations I have to do. So me being a math teacher, of course, I work out a ton of problems on the board in front of students every day. And in these problems, albeit I can be doing calculus or pre-calculus or trigonometry or some other thing, of course, there's always embedded in that some form of arithmetic. And when doing the arithmetic I have to do, there are a lot of little tricks that I use to do some of my calculations when it's applicable, and it makes the calculation I have to do a lot easier. Sometimes students marvel at the fact of some of the calculations I can do. And I always tell them it's not that I'm more intelligent than you, it's just I know some things you don't know, and I try to show them some of the tricks when I can. So what I'm going to do today is show you some of the tricks that I use to help me do some of the arithmetic that I have to do on a daily basis. And you know, when I was a young person, I would play different games with numbers and look at numbers. I would look at all the squares and look at certain sets of numbers and try to notice patterns. And pretty much everything in math is dealt with patterns, and especially in arithmetic, basically everything has a pattern related to it. Sometimes recognition of the pattern makes your life easier, makes calculations easier to do. And sometimes, you know, the pattern is a little more complicated than just doing the calculation anyway. But one thing is when you multiply numbers that have a difference of 2. And I'll start off looking at numbers where I know you know their product, and then find a pattern and use that pattern to do bigger numbers where you probably don't know their product. So for instance, 6 times 4 is 24, right? Those numbers have a difference of 2. 8 times 6 is 48. Those numbers have a difference of 2. 10 times 12 is 120. Those numbers have a difference of 2. Now those 3 examples I use, of course, are all numbers where you know their difference. But I want to look at where you know their product, But I want to look at their product in relationship to the number that's in the middle of those 2 numbers. So let's go back to 4 times 6, which we said was 24. What's the number in the middle of 4 times 6? That's 5. And 5 squared is 25. If you take 1 off that 25, you get to 24 for 6 times 4. Let's look at 8 times 6. 8 times 6 is 48. What's the number in the middle of 8 times 6? It's 7. 7 squared is 49. 49 minus 1 is 48. 10 times 12 we said was 120. Well, what's the number in the middle? 11. 11 squared is 121. Take 1 off, you get 120. Now, why does it work like that? So imagine a number in the middle, which I'll call x, in the middle of 2 numbers being multiplied. And so the number that's bigger, that's 1 bigger than x, we can call x plus 1. And the number that's 1 smaller than x, we can call x minus 1. So what happens when we have x minus 1 times x plus 1? These are the 2 numbers that have a difference of 2. We get x squared minus 1, the difference of squares. X minus 1 times x plus 1 is x squared minus 1. And what's x? X is the number in the middle. So anytime we multiply 2 numbers that have a difference of 2, we can simply square the number in the middle and subtract 1. Now, for this trick to be beneficial, you know, you have to know your squares. And actually in our next trick, we're going to look at some tricks of how to square some pretty complicated numbers. But for this trick to work, you have to know your squares. And the only time this trick will work is when you had a pair of numbers that have a difference of 2, and you don't know what the product of those pair are, but you know the square of the number in the middle. So let's say, for instance, we're multiplying 74 times 76. And 74 times 76 would be 5,624. Why? Because 75 squared is 5,625. And then you subtract 1. Again, I know 75 squared better than I know 74 times 76. Let's say you have 50 times 52. Well, 50 times 52 would be 2,600. Why? Because 51 squared, the number in the middle, is 2,601, and take 1 off, you get 2,600. Again, I know 51 squared better than I know 50 times 52. Take another example, 94 times 96. 94 times 96 will be 9,024. Why? Because 90, the number in the, 95, the number in the middle, its squared is 9,025. Now, if you notice on these examples, as the numbers got bigger, if you really paid attention, the number in the middle either ended in 5 or 1. Why? Because there's also a trick for squaring numbers that end in 5 and 1. So that's the little trick I'm going to address next. So squaring numbers that end in 5. So let me rattle off some squares of some numbers that end in 5 and see if you can notice the pattern. So let me start with 15. 15 squared is 225. 25 squared is 625. 35 squared is 1225. 45 squared is 2025. 55 squared is 3025. 65 squared is 4225. Now, one thing you should notice on all those problems is they all end in 25. So any number that ends in 5 squared is going to end in 25, no exceptions. So anytime I square a number that ends in 5, I know it's going to end in 25. So for instance, 75 squared, that's going to end in 25. Now, how do I get the numbers before the 25? Well, it depends on the number before the 5. And for instance, look at 15 squared, it's 225. Okay, what's the number before the 5? 1. And what we do is we multiply that number by the next consecutive integer. 1 times 2 is 2. 225. Let's look at 25 squared, which is 625. What's the number before the 5 in 25? 2. The next consecutive integer is 3. 2 times 3 is 6. 625. 35 squared is 1225. Why? Because 3 times 4 is 12. 55 squared is 3025. Why? Because 5 times 6 is 30. 75 squared is 5625. Why? Because 7 times 8 is 56, and so on. So we can go on. So as long as we know the number that's in front of the 5 times its next consecutive integer, then we can square any number that ends in 5. For instance, we can square 125, which would be 156.25, because 12 times 13 is 156. So that's the rule for squaring numbers that end in 5. What about squaring numbers that end in 1? So let's look at a few of the numbers that end in 1 and their square. So 11 squared is 121. 21 squared is 441. 31 squared is 961. 41 squared is 1681, and 51 squared is 2601. Now, how do we get those numbers? So if we look at it, let's go back to 11 squared. What we're going to do is we're going to look at the number. We're going to take 1 off of the number and look at 10 squared, because that's a very easy calculation to do. 10 squared is 100. And all we're going to do is take 10 plus the number we actually were squaring. 10 plus 11, 21, 121. Look at 21 squared. Well, we'll take 20. 20 squared is 400. That's easy. And then 20 plus 21 is 41. So 441. 31 squared. 30 squared is 900. 30 plus 31 is 61. 31 squared is 961. 41 squared. 40 squared is 1600. 40 plus 41 is 81. 41 squared is 1681, etc. And you look at 51 squared. 50 squared is 2500. 50 plus 51 is 101. 2500 plus 101 is 2601. So you can continue this process on. For instance, if you do 90 squared. So 90 squared is 8281. Why? Because 90 squared, excuse me, when I said 90 squared, I mean 91 squared. 91 squared is 8281. Why? Because 90 squared is 8100, and 90 plus 91 is 181. So 8100 plus 181 is 8281. So that is the process for squaring numbers that end in 1. I only got a little time left. There's a couple more I want to do. Multiplying numbers by 25 and multiplying numbers by 125 is how we'll close this out. So we multiply numbers by 25. Okay, this is only going to be beneficial if the number is divisible by 4. Why? Because 25 is equal to 1/4 times 100. 25 is the same thing as 100 divided by 4. So when you multiply a number by 25, all you have to do is divide the number by 4 and then multiply the number by 100. For instance, 88 times 25 is 2200. 64 times 25 is 1600. 8 times 25 is 200. So in each case, I'm dividing the number by 4 and multiplying by 100, which is really adding 2 zeros. Of course, as long as the number is fully divisible by 4. And the rule for 125 is similar, because 125 is 1 over 8 times 1,000. 125 is like 1,000 over 8. So if you multiply a number by 125, you can simply divide the number by 8 and multiply by 1,000. Of course, this is only a good rule to use if the number you're multiplying by 125 is, of course, divisible by 8. To look at some examples, 32 times 125. Oh, that'll be 4,000, because 32 divided by 8 is 4, and then times 1,000. 64 times 125, that would be 8,000. Because 64 divided by 8 is 8, and then you multiply by 1,000. 56 times 125, that would be 7,000, because 56 divided by 8 is 7, and then of course you add 1,000. So that is just some of the math arithmetic tricks that we use. There's tons and tons more out there. Some of them I use, some of them I don't find as beneficial, but you can look at any type of arithmetic and you can find some pattern to that arithmetic, and you may find something that's very easy to do to make your calculations easier. So we'll end this particular video on arithmetic tricks. Hope you enjoyed it, got something out of it, and we'll see you next time.